Starting with the next exercise, exercise 4.6. So students, why did we learn determinants? So these are the applications of determinants. Means, where is determinants used? Determinants is used to solve system of equations, system of linear equations like this and like this. So here, see, you can also solve equations which we have studied in class 7th and 8th, okay, by elimination method or multiplying the first and the second equation with 5, so that the x will not what is y, you will be less that, right? Linear solving simultaneous equations by elimination method, cross multiplication method and all. So determinants is also used to solve linear equations like this and this, okay. And in application field, so when we come to the softwares where we used some softwares which are used for real world. So for example, I know few softwares like StatPro and all, okay. So in those softwares we use determinants only, okay. We are not using the cross multiplication method and elimination method to solve the equations like this. So these both are basic equations, okay, where there are only 3 variables and here there are 2 variables. As the variables increase, okay, the equations also get increased. So applying cross multiplication method and elimination method to more number of equations become a tedious process. In order to make that simple, okay, we are going to use determinants to solve them. So these determinants are also used in most of the applications or softwares which is used for the practical life. Alright, so this is the applications of determinants. So we'll learn, so basic will start with 2 variables and 3 variables. So the same principle is applicable for if more number of equations are given. Alright, so let us start here. I think you can differentiate the colors, right? So you see the numerical coefficients are in green color, the variables are in blue color, and on the right hand side it is written in orange color. I hope the color you can differentiate between the colors. The same is applicable here. Variables are blue, numericals are green, and on the right hand side it is written in orange. So this is just to separate the things. So now let us start with this solution. So how do we solve these linear equations with help of matrix? So students, the numerical whatever is written here, numerical coefficients, so that will take it as matrix A multiplied with the variables. Let us take that as matrix X, which is equal to this, we will take it as matrix B. Now what do we want? We have to solve this, right? Which means you have to find out what is X and what is Y. That's all. So you basically need this. This is what X and Y variables. These are numerical coefficients and this is the right hand side. Send this A to that side, what will happen? So we will be getting X is equal to A inverse of B. Correct. X is equal to A inverse of B. Now what we'll do, students? So again A inverse. So this is 2 cross 2 and this is 2 cross 1. 2 cross 2 into 2 cross 1. So 2 and 2 are matching here again. So the matrix multiplication is possible. So just make sure of that. Now let us write matrix A here. So matrix A can be written like this, right? Matrix A can be written as 5, 2, 3, 2. Only the green. Next, matrix X will write. Now you write the blue color things. So that is nothing but X, Y, which is equal to matrix B, the orange ones, 3 and 5. Send A to that side. So what we'll be getting? XY equals 5, 2, 3, 2, the whole inverse into 3, 5. So what is A inverse, students? A inverse we have studied, right? What is A inverse formula? A inverse is nothing but like this. A inverse is equal to adjoint of A divided by determinant of A. So what is adjoint of A? A we know, right? What is A? Here we have A. What is adjoint of A then? Adjoint of A will be equal to, interchange the principal diagonal elements, so that is nothing but 2 and 5. Change the signs of the other diagonal, so that is becoming minus 3 and minus 2. So this is adjoint of A. What is determinant of A? Determinant of this. So determinant of A also will write. Determinant of A is nothing but 10 minus 6, which is equal to 4, and this is not equal to 0. So if this is not equal to 0 means what? Inverse of A exists, and also this means the solution is having a unique, the equations are having a unique solution. Okay, so adjoint of A and determinant of A we got. So let us find out the inverse of A now. What is inverse of A? A inverse equals adjoint of A 2 minus 2 minus 3 and 5 divided by determinant of A is 4. So therefore A inverse can be written as 1 by 2, correct? This 4 will get divided by 4 here. 2 1s are 2 2s are minus 1 by 2. Here it will be minus 3 by 4 and here it will be 5 by 4. What is this? This is our A inverse. Now in this place, so this is A inverse, right? So in this place you have to write this one. So again we'll write x y, which is equal to 1 by 2 minus 1 by 2 minus 3 by 4 and 5 by 4 into 3 and 5. Now matrix multiply this. What will you be getting? First row into first column, second row into second column. Okay. So this is 2 cross 2 and this is 2 cross 1. So we can matrix multiply. See, these both are same. What would be the order of the product? 2 cross 1. So we'll write 2 cross 1 like this. Okay, now matrix multiply. 1 by 2 into 3. So that is nothing but 3 by 2. Minus 1 by 2 into 5. So that is nothing but minus 5 by 2. Same thing here. Minus 3 by 4 into 3. So that is becoming minus 9 by 4. And here 5 by 4 into 5, that is becoming 25 plus 25 by 4. Further simplifying this, what will you be getting here? Denominators are same, so write the denominator 2. 3 minus 5 is minus 2. Here also denominators are same, so write by 4 plus 25 minus 9 is 16. Is that correct? Yeah. 25 minus 9 is 16. So this is becoming 4 1s are, 4 4s are, 2 1s are, 2 1s are. So here directly we can write minus 1 and 4. What are these? These are the values of x and y. So what is the value of x, students? So from whatever we solved, what is the value of x? Here we can write x is equal to minus 1 and y is equal to 4. Check whether these values are satisfying these equations. Put minus 1 here, it will become minus 5. And here you put 4, minus 5 plus 8. So that is equal to 3. So these values are satisfying the first equation. Again here, minus 3 plus 8. So 8 minus 3 is 5. Again satisfying the second equation. So this is your right answer. So understood how are determinants used to solve the system of linear equations. So here it was only two variables, right? X and y. Now here we'll be solving three variables, students. So same thing, Ax is equal to b. X will keep it on that side, A will send it on this side, it will become A inverse of b. So A inverse here will be 3 cross 3 and this is 3 cross 1, so matrix multiplication is applicable. Alright, so directly we'll start with this step, or we will find out what is A inverse first. Okay, so let us start the solution for this. Solution, A dot x equals b, x equals A inverse of b. Okay, so A inverse is nothing but, on this side we'll start. A inverse is nothing but adjoint of A divided by determinant of A. How do we find out the adjoint of this? So what is matrix A? Matrix A equals only the numerical coefficient. This is 2, 3, 3, 1, minus 2, 1, 3, minus 1 and minus 2. Cross check it once again. 2, 3, 3, 1 minus 2, 1 and 3 minus 1 minus 2. Write down the cofactors, or how do we find out the adjoint of A? First take the transpose of this. So transpose of this would be writing the rows as columns. So 2, 3, 3 is a row, right? Write it as a column. 2, 3, 3, 1 minus 2, 1, 3 minus 1 minus 2. Transpose is done. Now we have to find out the minors of each and every minors of each and every entry here. So to find the minors, we have to know the cofactors. So plus minus plus, minus plus minus, plus minus and plus again. We are going to find out what now? Minors of this. So what are the minors here? So minor of 2, plus 4, plus 1. So plus 4 plus 1 is 5. 5 multiplied with this cofactor, it is becoming 5 only. Okay, next, minor of 1, minus 6 plus 3, correct? Minus 6 plus 3 is minus 3. Minus 3 multiplied with the cofactor of 1, that is minus. Minus into minus will become plus. Moving on to the next one. So this is 3 plus 6, correct? Minus 6 it is, minus into minus is plus, but so 3 plus 6. 3 plus 6 is 9. 9 multiplied with the cofactor plus, so it is 9 as it is. Next, cofactor of 3. So this is becoming minus 2 minus 3, minus 5. Minus 5 multiplied with the cofactor plus 5. Cofactor of minus 2, sorry, minor of minus 2. So that will become minus 4 minus 9. Minus 4 minus 9 is minus 13. Minus 13 multiplied with the cofactor plus, so that is becoming minus 13 only. Next, minor of minus 1, so that is becoming 2 minus 3. 2 minus 3 is minus 1. Minus 1 multiplied with the cofactor minus here, so it will become plus 1. Next, minor of 3 minus 1 plus 6. Minus 1 plus 6 is 5. 5 multiplied with plus, it is 5 as it is. Next, minus 2 minus 9. Minus 2 minus 9 is minus 11. Minus 11 multiplied with the cofactor minus, so it is becoming plus 11. And minor of minus 2, that is minus 4 minus 3. Minus 4 minus 3 is minus 7. Minus 7 multiplied with the cofactor plus, so it is minus 7 as it is. So what is this, students? This is our adjoint. So the very first step is what? Transpose with the cofactors. After this, we are going to find out the minors of each and every entry in this particular matrix. So this is our what? Adjoint of matrix A. Now next, what we have to find out? Determinant of A. So determinant of A is equal to, so A, this is our A, right? So here also we'll write the cofactors plus, minus and plus. Now solve this determinant. So it will become plus 2 of 4 minus of minus 1 minus 1 of, so here minus 3 of minus 2 minus 2 minus 3. Minus 2 minus 3 is minus 2 minus 3, we'll write it minus 5. Minus 5 into minus 3 we have to do later on. Next, plus 3 of minus 1 plus 6. Minus 1 plus 6. Now here again, in the next step, so let us keep this as it is, solve it inside the bracket first. So this is plus 2, open the bracket, minus 3, open the bracket, plus 3 again, open the bracket. Now see what is coming inside the bracket. 4 plus 1, 5, minus 2 minus 3 minus 5, and 6 minus 1 is 5. 5, 5, 5, 5, 5, 5. The only change is this is plus 5 and this is minus 5. Why is this plus 5? Because see the cofactor here, it is minus. So this minus 5 is multiplied with this cofactor, that is why we are getting plus. Understanding? So no need to solve the determinant also perfectly. So just to show you this, whatever we are getting here, the same thing we are getting here, 5, 5, 5. Only this is becoming minus. Why? Because minus 3 minus 2 is minus 5. Why did it become plus here? Here why did it become plus is because this minus 5 got multiplied with the cofactor of 3. And what is the cofactor of 3? It is minus. So minus 5 into minus is plus. Are you getting this trick? So just you can use this. No need to solve this, but you must be careful of the signs. So if there is any confusion, you can always opt to the conventional method. So solving this further, what we'll get? This is becoming 10. This is becoming plus 15 and plus 15. Correct? 10 plus 15 plus 15. 15 plus 15 is 30. 30 plus 10 is equal to 40. What is this 40? This is 40 is nothing but our determinant of A. And what is this? This is our adjoint of A. This is adjoint of A. This is determinant of A. So now we can find out inverse very easily, right? What is A inverse? So here you can see adjoint of A divided by determinant of A. So we'll not divide 40 to each and every element. So we'll just keep 40 outside. So here the numbers were divisible. Two numbers were divisible. Here not all the numbers are divisible. So we'll keep 40 outside as it is. So now in the place of x, what can we write, students? Here in the place of x. In the place of x we can write x, y, z. Correct? X, y and z. Now what is A inverse? A inverse is nothing but 1 by 40 of, adjoint of A is nothing but 5, 3, 9, 5 minus 13, 1, 5, 11 and minus 7. And what is B, students? B is nothing but this matrix. So that is 5 minus 4 and 3. Correct? 5 minus 4 and 3. Now you have to multiply these both, then divide it by 40. You will be getting the values of x, y and z. So let us first multiply this. What is the order? 3 cross 3. What is the order here? 3 cross 1. What would be the order of the product? So that is nothing but x, y, z equals, order of the product is 3 cross 1. Means the same thing. So we'll write 1 by 40. So 3 cross 1. We will solve it here right now. How is matrix multiplication done? Row into column. 5 5s are 25. 3 into 4 is minus 12. So 25 minus 12, 9 3s is plus 27. So 25 plus 27, this will give us 52. 52 minus 12, 52 minus 12, 40. Okay, next. First row into first column is done. Second row into second column. Now 5 5s are 25. Minus 13 minus 4. So this minus into minus will become plus, right? So we'll write plus. 4 3s are 12. So this is becoming 52. Okay. 1 into 3 is plus 3 again. So add this up. 25 plus 52. How much? 77. 77 plus 3, 80. Right? 80 as it is. Next. Third row into first column. 5 5s is 25. Minus 44. Minus 21. Correct? 25 minus 44 minus 21. So this is becoming minus 63. Minus 63 plus 25. So we'll do it here again. Minus 63 plus 25. So impossible to subtract, right? So from here we'll borrow 5, 1. 13 minus 5 is 8. 5 minus 2 is 3. And with the negative symbol, minus. So I think this is not divisible by 40. You see, this was divisible by 40. This is also divisible by 40. So 5 into 5 is 25. 11 into minus 4 is minus 44. Minus 7 into 3 is minus 21. Minus 65 plus 25. Oh, it is 65, students. I have written 63 here. Okay, so that is a mistake again. So minus 65 plus 25. So that is becoming minus 40. So now minus 40 is divisible by 40, right? Correct. So now what are x, y, z values? Therefore, x, y, z is equal to, take this 40 inside, 40 by 40, 80 by 40, minus 40 by 40, which is equal to 1, 2 and minus 1. So therefore what can we write here? Therefore x equals 1, y equals 2 and z equals minus 1. These are values of x, y and z. So whenever you finish or get the values of x, y and z, how do you know that this is correct? Or so first of all, this must be divisible. If it is not divisible, see in this case, so we know that there is some mistake here. So the mistake was 44, 21. Yeah, so in addition we did a mistake, correct? 44 minus 21 is minus 65. We have written 63 there. Very basic mistake. Okay. So just be careful when you are calculating, even with the cofactors and all. Any one small mistake, okay, you will not be getting the answer here. So you have to be very careful. So matrices and determinants, basically these both chapters test your accuracy and precision. Okay. So anywhere you go wrong, the answer will not be coming. So this is only to test your accuracy and precision. So x, y and z values, see whether these values are right or wrong, substitute in this equation. Any one equation we'll take this equation. Okay. X is equal to 1, y is equal to 2. So that will become minus 4. Minus 4 plus 1 is minus 3. Minus 3 minus 1. Minus 3 minus 1 is how much? Minus 4. So this is satisfying, right? So you can conclude that this answer is right. So if you want, you can also substitute these values in equation 1 and equation 2, and obviously it will get satisfied. So this is the right answer. So moving on to the next question. Starting with the next question, number 16. This is the last question of this exercise. So this is a word problem, students, as you can see here. So read out the question first. The cost of 4 kg onion, 3 kg wheat, 2 kg rice is rupees 60. Okay. Next, The cost of 2 kg onion, 4 kg wheat, 6 kg rice is rupees 90. The cost of 6 kg onion, 2 kg wheat and 3 kg rice is rupees 70. Find the cost of each item per kg by matrix method. So what we'll assume here is, okay, we will take onion as X, wheat as Y, rice as Z. X, Y, Z, X, Y, Z, X, Y and Z. Correct? So we will write this in the matrix form now. So before we write it in the matrix form, we'll write it in the form of equation first. Okay. So solution, how can you write it this? How can you write this as an equation? 4 into X, 4X plus 3Y plus 2Z equals 60. Correct? Next, 2X plus 4Y plus 6Z equals 90. Next, 6X plus 2Y plus 3Z equals 70. Correct? 4X plus 3Y plus 2Z, 2X plus 4Y plus 6Z and 6X plus 2Y plus 3Z. So we got the equations. So we have to find cost of each item per kg, means basically we have to find out what is X, Y and Z. So now write this in the matrix form. So we will write determinant of the numerical coefficients 4, 2, 6, 3, 4, 2, 2, 6, 3. This is A dot. What is X now? X is the variables into X, Y, Z. Okay, so this is a square brackets here. So this is our X, which is equal to B, that is nothing but 60, 90 and 70. 60, 90 and 70. Now students, what we have to do, send A on this side. What will happen? X will be equal to A inverse of B. And what is A inverse? A inverse will do it on this side. So what is A inverse, students? A inverse is nothing but adjoint of A divided by determinant of A. We'll first find out adjoint of A. Directly take the transpose. So 4, 3, 2 is the first row, right? Write it as a column. 4, 3, 2. Next, 2, 4, 6. Next, 6, 2, 3. Transpose is done. Okay. So now write the cofactors. After writing the cofactors, we have to find out what are the minors. So plus, minus, plus, minus, plus, minus, plus, minus, plus. Now find out the minors of this. So which is equal to, so this will be our adjoint of A. 4, 12 minus 12, 0. 9 minus 4, 9 minus 4, 5. 18 minus 8, 10. Correct? So if this is gone, 4 3s are 12, 6 2s is 12. Everything all right? So 4 3 2, 2 4 6, 6 2 3. Just cross check once. 4 3 2, 2 4 6 and 6 2 and 3. So always cross check, students. One small mistake you do here, so there will be a mistake here, there will be a mistake here, there will be a mistake here. That error gets on accumulating and finally you will get the wrong answer. You will be awarded with 0 marks. Just to avoid that, always cross check, be very careful. As I said you before, the matrices and determinants chapter is used to check your precision and accuracy. So be very careful with that. So again, 12 minus 12 0, 9 minus 4 5, 18 minus 8 is 10. Moving to the, okay, so here we did not multiply with the cofactor, see. So that is another mistake. So this 5 must be multiplied with minus sign, right? So this will become minus 5. Understood? So everything else is fine. Now going on to the next one. So 6 minus 36. See, 3 2s are 6 minus 36. So 6 minus 36 is minus 30. Minus 30 multiplied with the cofactor. What is the cofactor here? Minus. So minus into minus will become plus 30. So write 30. Next, 12 minus 12. Correct? 3 4s are 12. 2 6s are 12. 0. So this is 0 as it is. And the last one here, 24 minus 4. So 24 minus 4 is plus 20. Plus 20 multiplied with the cofactor, minus is there here, so right, minus 20. So for 2, 4 minus 24, minus 20, minus 20 multiplied with the cofactor, plus 20, so it will become minus 20. Here again, 8 minus 18, correct? 8 minus 18 is minus 10, minus 10 multiplied with the cofactor minus, so it will become plus 10. And the last one, 16 minus 6, so 16 minus 6 is 10, so 10 we will write as it is. So what is this? This is our adjoint. Adjoint is done. Now we have to find out the determinant of A. So determinant is, so we'll directly write from there, plus 4, open the bracket, 12 minus 12, so this is 0, minus 3, open the bracket, minus 3, 6 minus 36. Okay, and 4 minus 24. So it is plus 2 into 4 minus 24. This is what determinant of A, which is equal to, this is becoming 0. So minus 30, this is minus 30 into minus 3. Minus 30 into minus 3 is plus 90, correct? Minus into minus is plus, 30 into 3 is 90. So this is becoming minus 20 into 2. Minus 20 into 2 is minus 40. So here we'll be getting how much? Plus 90 minus 40, this will be equal to 90 minus 40 is 50. So recheck this once again. 12 minus 12, 0. 3 2s are 6 into 6. 6 into 6 is 36. 6 minus 36 is minus 30. Minus 30 into 3 plus 90 plus 2. This is becoming 4 minus 24. So 4 minus 24 is minus 20. Minus 20 into plus 2 is minus 40. So 90 minus 40 is 50. So this is our determinant of A. So now moving on to the next one, what we have to find out? A inverse into B, right? A inverse is nothing but adjoint of A divided by determinant of A is 50. So adjoint of A we'll find out the inverse of A first. So inverse of A is given by 1 by 50 into 0 minus 5 10 30 0 minus 20 minus 20 10 and 10. And what is B? B is 60 90 and 70. 60 90 and 70. So this is 3 cross 3 and this is 3 cross 1. Matrix multiplication is possible. What will be the order of the product? The order of the product will be 3 cross 1. So 1 by 50 as it is. 1 by 50. Now start multiplying this. 0 into 60 is 0. Minus 5 into 90. This is becoming minus 450. Okay, and 10 into 70. So that will become plus 700. Correct. Next. 30 into 60. 6 3s are 18. Followed by 2 zeros. So it is 1800. 0 into this is 0. Minus 20 into 70. That will become minus 1400. Next. Minus 20 into 60. So this will become minus 1200. Minus 1200. Plus 9 ones are 9. Followed by 2 zeros. And 7 ones are 7. Followed by 2 zeros. Solve this now. 700 minus 450. So 700 minus 400 is 300. 300 minus 50 is 250. So here we'll write 1 by 50 of 250. Correct. Next 1800 minus 1400 will be equal to 400. And 1600 minus 1200 is again 400. So here again 0 0 cancel. 5 ones are 5 5s are. So this is 5, 0 0 cancel. So this is 8, 0 0 cancel. This is 8 again. So this is equal to X, Y and Z. Check whether these values are satisfying the equations. So let us put X is equal to 5. So this is becoming 30 plus 16, 46 plus 24. 46 plus 24. So 46 plus 24, 50, 60, 70. So these equations or these values of x, y and z are satisfying this equation. So similarly these values will also satisfy this and this. So therefore we can write price of onion, price of wheat, and finally we can write price of rice per kg equals rupees 5, rupees 8 and again rupees 8. Check this. 5 fours are 20 plus 24, 20 plus 24 44, 44 plus 16 60. Same thing here. 10 plus 32 42, 42 plus 48 90 again. Understood? So this is the answer. So here we have finished the last question of exercise 4.6. I'll be seeing you in the next class with the next chapter. Until then, take care and tune into Vista's learning. Thank you.